Hi everybody, today we're going to talk about horizontal pressure on a wall will change at different heights of the water with different shapes. Today the shape we're going to be using is a trapezoid shape, so I'm going to write that down. Let me make sure I didn't screw that up. So horizontal pressure on the wall will change at different heights of water on the wall due to a trapezoidal shape. So what we know is F is equal to P times A. We know from homework 1 that our variables for the pressure equation is dP over dZ is equal to negative PG. And then from there, we'll go over and we'll have the integral of P2, P1 of D. P is equal to negative P of G, and then Z2, Z1, and then DZ. And then from there, you'll just get P2 minus P1 is equal to negative PG delta Z. And then we can say that Z2 is equal to H. So we'll write over here, as it's in frame, Z2 is equal to H. And we can also put Z1 is equal to 0. And then from there, we can also use gauge pressure is equal to 0. So I'm going to write gauge pressure is equal to 0. So that we can say P1 is equal to, so we'll do P1 is equal to PATM, which is equal to 0 PA. So Z1 can equal 0. So from there, the equation we will have with P1 being equal to 0, that will go away. So we will end up with P2 is equal to negative PG delta Z2, because Z1 is equal to 0. We again take the original equation of F is equal to P times A and substitute that back in. So if we substitute F equals P times A back into our equation here, what we'll have underneath it is F is equal to negative PG Z2A. And then from there, I'm going to start a new sheet of paper. I'll move this over. If we need to reference this at all, we'll do that. So our area is changing since the base on H, the height of the water on the wall. So it's changing as the water goes up. So our area is changing since it is based on H. And that's the height. We'll do H is equal to height of water. So we have from this sheet before, we're going to go off of this equation here. We have F is equal to negative PG Z dA. Since it changes in height, we're going to have, we'll go down, since changes in height, we will end up getting f is equal to negative pg z w dz. And then we're going to take the area of the trapezoid and rearrange it. So we will get area is equal to t plus b over 2, and then we'll have z here. There's my 2. And then we will move this over to rearrange. So we're going to get w minus b over 2 is equal to m times z plus b over 2. And then we know that slope here, slope is equal to y equals mx plus b. So we also have y minus b over x, and then we'll multiply by 1/2. And then we'll draw out this trapezoid here. Do not critique my drawing abilities. Unfortunately, I'm not great at them. There's our trapezoid, and we're going to draw our dashes. And we'll have this as a half. This is going to be t. This is going to be b. This is going to be t minus b. This smaller section here is also going to be a half. And then this here is going to be our m, which is the slope of the line. And then here is going to be our h. So we have two triangles. So we have m is equal to 1/2 t minus b over h. So if we plug that back into the equation, we'll have f of h, it's an h, and then this is 0, of df equal to -2, and in here we will have z is equal to h, and then z is equal to 0 of p g z, and then inside we'll have m times z plus b over 2 dz side. And after this is all derived, we end up getting f of n is equal to negative p of g, and this will be mz cubed over 3 plus bz squared over 4 inside our parentheses, and then the limit is z equal to h over 0. And then going to our third sheet of paper for our final equation. Here, fresh sheet of paper, we get f of h is equal to -2 p of g mh cubed over 3. Ignore that, that is supposed to be a plus, of bh squared over 4. And then we're going to substitute m for our final equation. So we'll substitute in m for our final equation being f of h is equal to -2 p of g, with this being t minus b, and then we'll have h cubed over 2 times 3 times h plus b h squared over 4. Actually, let me correct this. This should be a lowercase. This should also be a lowercase. And that is our final equation there when we're all said and done.